So when I have a, pardon me, an absolute value equation, I'm going to have two answers. The reason for that is if I have, and this is just a side note, if I have the absolute value of x equals 3, x can equal two things. It can either equal 3 or it can equal positive 3. So to solve, I have to set it equal to both. So when I am solving a more complex equation with it, I need to get the absolute value part alone. So to do that, I need to get everything else to the other side. So I'm going to add 5, and these numbers are not going to come out very nicely, so I apologize. So 2 times the absolute value of x minus 3 equals 1/2 x plus 9. I need to get rid of that 2, so I'm going to divide by 2. So I have the absolute value of x minus 3 equals 1/2 divided by 2 is 1/4 x plus, and I can leave that as a fraction, or you can also put it as a decimal. You could use 0.25 and 4.5 if you preferred, because those are terminating decimals. I wouldn't expect fractions to necessarily show up on your final, but, you know, I threw the review together pretty quick, and my son was throwing up at the time. So, all right, so now I have that absolute value alone. That's when I need to split it into 2. The first one is going to be the positive, and nothing's going to change on the positive. I have x minus 3 equals, for simplicity's sake, I'll go 0.25x plus 4.5. And then on the negative side, I'm still going to have the x minus 3. And then instead of a positive 0.25, I'm going to have a negative 0.25x, and then minus 4.5. And I'm going to run out of space. And then I just need to solve each of those separately. So get the x's to one side, so minus 0.25x, bless you, and get the numbers to the other, adding 3 to both sides. So I have negative, or sorry, not negative. So 1x minus 0.25x is going to give me the 0.75x equals 4.5 plus 3 is 7.5. Divide by 0.75, and I get x equals 10 for one of my answers. Any questions on that? So for the negative version, it's the same process, except I'm going to add 0.25x to both sides and add 3 to both sides. So I have 1.25x equals negative 1.5. Which is going to give me a negative 1.2 after I divide. So that's solving an absolute value or nonlinear system, or sorry, nonlinear equation algebraically. It still looks fuzzy to me, that's bugging me. So we're going to jump down to the lower right-hand corner of that worksheet and do the nonlinear system algebraically. So when we solve nonlinear systems algebraically, it's generally going to be a very similar process to solving a linear system algebraically. Both of these two equations are set equal to y, so we set them equal to each other. So I have, and you have to write really small on this one, my apologies, negative x squared plus 8x plus 16 equals x squared plus 9x minus 5. When I have a quadratic equation, in order to solve it, what does it need to equal? 0. So I'm going to get everything over to one side. To avoid a negative leading coefficient, I'm going to get everything over to this side. So I'm going to add x squared, subtract 8x, and subtract 16. So I'm going to have the quadratic 0 equals 2x squared plus 1x minus 21. And I can solve this quadratic in one of two ways. What's one of those ways? Quadratic formula, and the other? Factoring. So I can do either one of those. The quadratic formula you can use every single time. The zero product property, not necessarily every quadratic formula or quadratic equation is going to be factorable. So I'm going to go ahead and show you the quadratic formula method. If you prefer factoring, then by all means do factoring. You should get the same answers either way. So the quadratic formula, x equals negative b. So negative 1 plus or minus the square root of b squared, so 1 squared, minus 4 times a, and a is 2, times c, which is negative 21, all divided by 2a. So all divided by 2 times 2. So when you're doing this on the calculator, you can do that whole square root part under 1. So the square root of 1 squared minus 4 parentheses 2, close parentheses, and then parentheses negative 21. So that should close out that entire thing. You just got to be careful with the parentheses in this case, because as soon as you close them without having another one, it ends that square root. So you want the square root over the whole thing. So that's going to give me 13. So the number I should get under here if I didn't do the square root is 169. So the next step here, x equals negative 1 plus or minus 13, all divided by 4. Any questions there? Splitting that off into the plus and minus because I have it as simplified as I can. Negative 1 plus 13 divided by 4 gives me 12 over 4. So one of my x's equals 3. The other one minus negative 1 minus 13 divided by 4 equals negative 14 over 4, which gives me negative 3.5. So I have two values for x's, but when I started my equation, how many variables did I have? Two variables. I had both an x and a y, which means I have to solve for both. So once you have your x's, you plug them back into one of those equations. It doesn't matter which one. I would probably use the second one to avoid the negative x. To find y. So I'm going to plug the first one in. So y equals 3 squared plus 9 times 3 minus 5. So y equals 9 plus 27 minus 5. So 36 minus 5. So y equals 31. So that particular point where those two parabolas are going to cross is the point 3, 31. The other one, I need to zoom out just a tad. The other one, I can plug into the same equation. I just need to plug in that negative 3.5. So y equals, this is where you have to be careful with parentheses when you're squaring a negative in the calculator. Negative 3.5 squared plus 9 times negative 3.5 minus 5. And I'm just going to plop that into the calculator as well. But make sure you put parentheses around that negative 3.5. And I screwed up somewhere. Sorry. Negative 3.5. Close that parentheses squared. I think that's where I messed up. Negative 3.5. Then minus 5. So negative 24.25. So that point of intersection, negative 3.5, comma, negative 24.25. This particular type of problem, the solving nonlinear equations or systems of equations algebraically, is probably the most work-intensive one you're going to have to do. It's a lot of steps and a lot to remember, so keep that in mind.